Guys, welcome back. We are going to work on lesson 7.3 today. It is a one-day lesson. We're going to be talking about proving that a quadrilateral is a parallelogram. It's very similar to lesson 7.2 because it's basically the converse of all the theorems that we learned in lesson 7.2. Okay, so let me present my screen and we will get started. All right, so we'll start with our vocabulary, which we already talked about both of these words. So just kind of, reviewing them again. So diagonals, a segment that joins two non-consecutive vertices of a polygon. All right. And then a parallelogram, a four-sided figure quadrilateral that has two pairs of opposite sides parallel. Okay, so top and bottom are parallel and sides are parallel. All right, so that is a review of your definition. Now jumping right into the theorems. So first we have parallelogram, opposite side, converse. So again, this is the converse of the theorem that we learned in the last lesson. The last lesson said, if I tell you that this is a parallelogram, then you're allowed to conclude that opposite sides are congruent. This is saying that if you have a four-sided figure like we have here, and you know that opposite sides are parallel, if you know that opposite sides are congruent, then you can conclude it's a parallelogram. And then once you conclude it's a parallelogram, everything we know about a parallelogram becomes true about this figure. Okay, so the way we write it in our proof or as a justification is opposite sides congruent implies parallelogram. So again, now that I know that the opposite sides are congruent, I can say, oh, well, this must be a parallelogram. And once you make that conclusion, that means opposite sides are parallel. It means opposite angles are congruent. It means consecutive angles are supplementary. It means diagonals bisect each other, right? So as soon as you make the conclusion that it's a parallelogram, all of that information is true. Okay, so next is the parallel opposite angle converse, which says if you have a quadrilateral and both pairs of opposite angles are congruent, then you know it's a parallelogram. Okay, so our justification would be written as this: opposite angles congruent implies parallelogram. So again, now that I know opposite angles are congruent, I know it's a parallelogram. Everything I know true about parallelograms is true about this figure. Let me move down. Okay, so this one is a little bit different. This isn't one of the converses, right? This is its own little theorem. It says opposite sides parallel and congruent theorem. Okay, it says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if you see a figure that looks like this, or doesn't have to be top and bottom, it could be, oh, pretend those are on the line. Could be like that. Right? If you have a figure where one pair are both parallel and congruent, okay, here I have top and bottom, both parallel and congruent, then you can say this is a parallelogram or this one is a parallelogram, and everything that you know to be true about a parallelogram is true about that figure. And the way we write it is one pair of op sides congruent and parallel implies parallelogram. Okay. All right, the next one If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So this is the converse of the theorem we already learned, because we know that if it's a parallelogram, that the diagonals bisect each other. So now we know if the diagonals bisect each other, I can conclude this is a parallelogram. And once again, everything I know about parallelograms is now true about this figure. So in a proof situation, I would say diagonals bisect implies parallelogram. Okay. All right. Let me move down. Okay, so this next chart just goes over what we just went through. Okay, so I'll write the justifications one more time. Ways to prove that a quadrilateral is a parallelogram. Okay, you can show that opposite sides are parallel. That's the definition. All right, you can, so let's write that opposite sides parallel implies parallelogram by the definition. You can show that opposite sides are congruent. So show op sides congruent. That implies a parallelogram. You can show that opposite angles are congruent. So op angles congruent implies a parallelogram. You can show that one pair of sides is both congruent and parallel. So one pair of sides congruent and parallel implies parallelogram. And finally, diagonals bisect each other implies a parallelogram. Diagonals bisect implies parallelogram. Okay. So let's use that information down here. So it says, are you given enough information to prove the quadrilateral is a parallelogram? Explain. So basically, you need to be able to use one of these 5 facts to explain that this is a parallelogram. Okay. So for the first one, is there enough information? Yes. And your justification? One pair of sides parallel and congruent implies parallelogram. What about number 2? Does it look like there's enough information, number 2, to say it's a parallelogram? Yes. Why? Diagonals bisect implies parallelogram. What about number 3? And the markings on 3, you can like faintly see, you can faintly see a second line right there. Okay. What about number 3? That's another yes. Why? Because opposite sides congruent implies parallelogram. All right. Let's move down to the next 3. All right, what about number 4? Do we have enough information? No, not enough info. All right. So they give you that one pair of sides are congruent and the other pair are parallel. But in order to use, let me just scroll up to the top so you can see which one I'm referring to. In order to use number 4, it needs to be the same pair of sides that are both congruent and parallel. So this is not enough information. Okay. What about number 5? Now, number 5 is not tricky, but let's think it through a little bit. If these angles are congruent, aren't those alternate interior angles? Alternate interior angles congruent implies parallel lines. What about these angles? Aren't they alternate interior angles? And if alternate interior angles are congruent, that implies parallel lines. So right off the bat, it doesn't match one of your 5 options above, but you can say alternate interior angles congruent implies parallel lines. And then once you make those markings, now you can say, yes, opposite sides parallel implies parallelogram. So sometimes you might have to do a little bit more work to make your conclusion, but then you have enough information. Okay. And the last one, let me erase what I have so far, just give myself more room. All right. So I know that this angle is congruent to this. Now, if I can somehow show that this angle is congruent to this, then I'd have opposite angles congruent and I'd know it's a parallelogram. Okay. What do the 4 angles of a quad have to add up to? They have to add up to 360. So if I take 120 plus 60 plus 60 plus my unknown and set it equal to 360, let's solve for your unknown. I'm just saying that that's x. Okay. So I have 120 plus 120 plus x equals 360. 120 plus 120, that's 240 plus x equals 360. Subtract 240 from both sides and x equals 120. So now that I know that this angle is 120, I can say yes, opposite, I should have done a comma. Let me fix that. Yes, comma. Yes, opposite my goodness. Opposite angles congruent implies parallelogram. Okay. All right, guys, I believe that is it. Let me just take a quick peek. Yes, that is all I was going to do. Let me just explain one quick thing that you might see in the homework. If I go down to one of the practice problems, just to illustrate. So as you know with math, it builds, builds, builds. You have to take things that you learned in other lessons and apply it to this lesson. So although I didn't do one of these examples in your notes, you have enough information inside your head to figure this out. All right, it says graph the quadrilateral with the vertices in the coordinate plane, then show the quadrilateral as a parallelogram. All right, so after plotting the points, how would you want to show that it's a parallelogram? What would you need to show? Well, you could show that opposite sides are parallel. How would you do that? Calculate slope, right? If you find the slope of the 2 sides and they're the same, they're parallel, and then the other 2 are the same, they're parallel. Could you do distance formula and find the length of the 2 sides and then the length of the top and bottom? So you have options. You could do slope or you could do distance formula. You could do slope and distance formula for the same pair, right? But these problems here are going to require you to either do slope or distance formula, which we've done throughout the year. So I think you can handle it. I just wanted to point that out before I send you on your own. Okay. All right. So that is it for lesson 6.3. I'll see you back here for the next lesson. Bye.